right, so on the first one, order of operations, P stands for E, MD. From left to right, and then AS is addition and subtraction from left to right. All right, so I've got parentheses, and there's more than one thing going on in there, so I need to finish out the whole parentheses before I work on anything outside of it. In the parentheses, what would I do first? The exponent. So the 3 squared is 9. And then what should I do next? Multiplication and division, but I don't have any, so I'm going to add and subtract from left to right. So 9 minus 5, that's 4, and 4 plus 2, that's 6. And then I'm going to rewrite everything that I didn't do yet. Kind of go into this other problem. All right, after I finish out my parentheses, I don't see any exponents, so I'm going to multiply and divide from left to right, right? So I'm going to start here. So I'm going to do 12 divided by 6, which is 2. And then I'm going to rewrite everything I haven't done yet. Then I'll multiply. 2 times 3 is 6, and write everything I haven't done yet. And then I'll add and subtract from left to right. So 5 plus 6 is 11, and 11 minus 6 is 5. Yep.
I thought you had to multiply before dividing.
It says multiplication and division from left to right. So if your problem has more than one multiplication or division, you always just do it in order from left to right. Always left to right if there's more than one.
Since it says multiply before division.
Right, but they just did that for the acronym to be able to put PEMDAS. But that's why we always say MD from left to right. Because PEMDAS is an easier acronym than if they switch the M and the D or the A and the S. It's just for helping memorize what you're supposed to do. All right, number 2, the square root of 256. What is it? 16. All right, and then the last 2, name the subsets to which each number belongs. So the subsets are the rational, irrational, natural, integer, whole. All right, so -5, is that a counting number?
No.
You can count to -5, -1, -2, -3, -4, -5, right? So it's a counting number. So I ask myself, is it natural? Is it a positive counting number not including 0? No. Is it a whole? Is it a positive counting number including 0? No. Is it an integer, a positive or negative counting number? Yes, and if you're an integer, then you're automatically rational. So this is integer and rational. All right, quick. Draven, what's the square root of 115? I don't know. It's about 11, but it's not exactly, right? Because we don't know what the square root of 115 is, so that must be a square root of a non-perfect square, which makes it irrational. That one's irrational. All right, homework questions. Anyone have any homework questions?
I have one on 18.
A question on 18? All right. Stack my book under there, so. All right, 18 said, simplify each expression so it was a square root of 0.25. So the square root of 0.25, you could just use your calculator. What is the square root of 25 though? So this could be 0.5. That's just a little trick I've learned over the years. If you don't know that trick, just go ahead and just use your calculator. All right, any other questions from the homework? All right, then make sure your name is on it, and then you can pass it up. Yeah.
I wasn't very.
Yeah. This was the homework from yesterday right there. Oh.
So I couldn't do.
Just go on to it and finish it at the end, and then you can bring it to me, okay?
In this one.
Yeah, we should have a couple minutes at the end.
Okay.
Alright, so today, whoop, just knock that over, it's fine. So today we're going to go for chapter 1, lesson 4, and it'll be the last lesson that we learn before we take our test. I usually do like half a chapter and then a test. So today is about the properties of real numbers. So yesterday we learned about the real number system and how to classify numbers based upon what they were in that real number system. Properties of real numbers is how do those numbers operate in math. Okay? And the first one is the commutative property. So these are also words that you're going to have memorized for your test. Okay? Commutative says that you can add or multiply in any order and the answer is still the same. So I'd write what I underlined down. Commutative. Add or multiply in any order. So in math, 5 times 2 is 10. What about 2 times 5? 10. It's still the same numbers. You just switch the order and the answer is still the same. That works with addition too. 3 plus 7 is 10. What about 7 plus 3? 10. You can switch the order in addition and the answer is still the same. Now that only works for adding and multiplying. It does not work for subtraction or division. We've got 4 of these, I think. All right, the associative property is almost identical to the commutative property, okay? The associative property says that you can group numbers with parentheses when adding or multiplying. So just the part that I underlined. So associative, you group numbers with parentheses when adding or multiplying, and the answer is still the same. That is the difference between commutative and associative. Commutative, they just have like 2 numbers that are being added or multiplied, and they just switch them. With associative, there's going to be more than 2 numbers, like 3 or 4 numbers, and some of them are going to be grouped with parentheses. But you could still add or multiply in any order, and that answer will be the same. What did parentheses tell you to do?
Multiply if you.
Right, but what do they tell? Why would parentheses be around something? Because you want to do it first. Good. You want to do that part first. So that's the purpose of associative, is saying that you can regroup things that you want to do first in the parentheses, and it won't change the answer. All right, the next one is the identity property. The identity property says that if you add 0 or multiply by 1, it stays the same number. So you just have to write down the part that's underlined. Identity, you add 0 or multiply by 1, and it stays the same number. So any number that you add to 0, 5 plus 0 is still 5. 12 plus 0 is still 12. Negative 9 plus 0 is still negative 9. 100 plus 0 is still 100. It doesn't matter what number you add to 0, it's still the same number. Multiplying by 1, 3 times 1 is 3, 7 times 1 is 7, 99 times 1 is 99. It doesn't matter what number you multiply by 1, the answer is still the same. So it keeps its identity. It stays the same identity number. Alright, and the last one is the zero property of multiplication. The zero property says that anytime that you multiply by 0, the result is 0. Any number times 0 is 0. 5 times 0 is 0. 99 times 0 is 0. 9,428,000 times 0 is 0. Any number times 0 is 0. And once again, these have to be memorized for your test. These and these words up here. So that means you got, what is that, 4, 5, 9 vocab words. Alright, so this is kind of going to kind of be like yesterday where they give you a number and you label it based off its subsets. They're going to give you an equation and they want you to name it based upon what property you see. Okay? So a couple people are still right, so I'll give you a second. And I was going to tell you all, yesterday I started posting these on Schoology. So if you forget how to do something or you forget what your homework is, at the end of the day you can go on Schoology and rewatch the lesson or figure out what your homework is if you forgot to write it down. Okay? Alright, so let's look at the directions here. It says which property is illustrated by each statement. So you're just going to say if it's commutative, associative, identity, or zero property. Alright, so this first one, 42 times 0 is equal to 0. This is the zero property. And the zero property says that anything times 0 is still 0. So I'm just going to write 0 here so that I know that that's the zero property. And I'm going to move this up. Alright, this next one, it looks like I'm adding. It looks like in this parenthesis was y plus 2.5, and now it's 2.5 plus 26. What property do we think that could be? Associative property. The associative property says that you can add in any order, but regroup with parentheses. So what's in the parentheses is now regrouped to be something else, which is why it's associative. Make sure when we label it associative, we don't stop there. Let's put a 0 on it. Okay? That spells a bad word. All right, this third one here, 10x plus 0 is equal to 10x. I know what this one could be? Identity. This is the identity property because the identity property says that you can add 0 to any number and it's still the same number, or you can multiply by 1 and it's still the same number. So this is identity. It stayed the same number. So I'm just going to call it ID. All right, this last one here, 5 plus 7 is equal to 7 plus 5. Commutative. This is the commutative property. We can add or multiply in any order, and the answer is still the same. The difference between number 2 and number 4 is that this one had parentheses that it regrouped stuff in. Commutative is not going to have parentheses that have stuff changing. Okay? All right, you all try these 3. 4x?
It's
Identity, because anything times 1 is still itself. Now, the second one I tried to trick you on, and the majority of you all did.
Community.
It's commutative. Now, the reason it's commutative, what did we say about associative? It regroups with the parentheses. What was in the parentheses, did it change?
It changed the position of y.
It just changed the position of the y and the z. Because associative, look up here. It had y and 2.5 in the parentheses. This one had 2.5 and 26. It actually changed what was inside of the parentheses. So it regrouped what was inside of the parentheses. This one didn't. This one has square root of y and z. This one also has square root of y and z. It didn't change what was in there. It just switched spots. So this is also commutative. And then what about the third one? It's also commutative. Does everybody understand the difference between what I'm talking about here? Is this one had something completely different in the parentheses. That means it regrouped what was in the parentheses. This one had the exact same thing in the parentheses. It just switched spots. So that's actually commutative. Okay? All right, so we're going to keep chugging along here. Let's see. All right, so it says you can use the properties for mental math and simplifying expressions. So you can check yourself with a calculator here, but I want us to think about, okay, mental math, how could I do this without a calculator? All right, so it says a movie ticket costs $7.75. A drink costs $2.40, and popcorn costs $1.25. What is the total cost for a movie, a drink, and popcorn? Use mental math. All right, so how would you figure, what operation would you use to figure out how much you spent? Addition, because when you find the total of something, you add up all of it. Now, if you didn't have a calculator, what should you add together to quickly figure out how much you're going to spend?
$1.25 and $7.75.
Correct, because the 75 cents and the 25 cents makes what? 1 whole dollar, right? If you tried to add $7.75 and $2.40, most people can't do that in their head quickly. Okay? So you want to figure out mentally what would be the easiest to add together. So that's why the $1.25 and $7.75 would be the easiest to add together first. So 25 cents makes this $8, right? And then $1 more makes $9. And then 9 plus $2.40. $11.40. If you use your calculator on your homework to check yourself, that's totally fine. I won't know. All right, I'm going to let you all try this one. A can holds 3 tennis balls. A box holds 4 cans. A case holds 6 boxes. How many tennis balls are in 10 cases?
I got a question.
Yeah.
Since this is mental math, do you have to show work?
No, there's no work. It's mental.
Okay.
All mind. All right, what operation should you be using? Multiplication. So here's how I did it. I just did it the way that I read it.
I got 720.
And that's right. All right, so if a can holds 3 tennis balls and a box holds 4 cans, if there's 4 cans and 3 tennis balls in each can, how many balls are in a box? 12, because 3 times 4 is 12. It says a case holds 6 boxes. So if there are 12 balls in 1 box, how many balls are in 6 boxes?
72.
72, because 12 times 6 is 72. And then if there are 72 balls in 1 case, how many balls are in 10 cases? 72 times 10 is 720.
I actually thought I got that wrong.
A lot of tennis balls. Alright, so the last part of this type, and then we got 2 more definitions that we're going to talk about, are some simplifying expressions. So this kind of comes from last year, just a little bit review. When you simplify expressions, you have to put together like terms and multiply things, okay? So this one right here, is this adding or multiplying? Multiplying. So this is 5 times 3n. When you multiply, you can multiply the numbers and just leave the variable on there. So 5 times 3n would be 15n. And you all probably talked about that last year when you all distributed. Like 2 times 3x is 6x. 5 times 3n is 15n. This one, in the parentheses, 4 plus 7b plus 8. Now, there's no number out here to distribute, but I do have some like terms. And remember, like terms are numbers or ones that have the same variable on them, which we're not there yet. So my like terms right here are 4 and 8. Yes, I know that this is in parentheses, but the associative property, and we can do this in our head, we don't have to write it out. The associative property says that you can regroup when adding and the answer doesn't change, right? So I can group together my like terms in my head. You don't have to write this. I'm just showing you what I'm thinking. 4 plus 8 plus 7b, because these are like terms that I could put together. And what is 4 plus 8? 12, so this could simplify to 12 plus 7b. So like I said, you don't have to write this part, but as long as you can mentally think, okay, the associative property says that I can add together 4 plus 8, because I can change the order and regroup with parentheses, I'm able to put together those like terms. All right, you all try these 2. You probably need your calculator on that one. Yeah.
I think I forgot my shoe.
No. Oh, yeah.
What did you do?
I'll give you a wipe and you can wipe them off in a minute.
Alright. Last year she told us that we can multiply like so 2.1 by itself and then multiply it with 4.5x. We would have to split the 4.5x so then we could have the
You can kind of tell me what I've been to this.
Yes and no.
Okay.
she told us to
It's full up and down.
Oh, okay, that's great. Well, if you go from here, like to the whole way, like from R and everything, but then you turn right, and that would be like a long way. I think it's 8.
It was like easy, but it was long. It took so long to multiply.
Yeah.
You can ask for a special education classroom, it's just 2 classrooms close by, and the more this way, and we'll go through the whole more.
All right, so 2.1 times 4.5x. What is 2.1 times 4.5?
9.45x.
Yeah, perfect. All right, and then the next one. Mentally, I know that I can put together the what?
The 6 and the 3.
The 6 and the 3, because their numbers are like terms. So 6 plus 3 is 9, so that's just 9 plus 4h. But let's say that Kyla wrote 4h plus 9. Is that okay? Yes, because addition is commutative. It doesn't matter the order you write addition in, it's still the same answer. All right, last slide here. It'll only take us a couple minutes to get through it. Our deductive reasoning and counter example, okay? Deductive reasoning is the process of reasoning logically from given facts to a conclusion, which you don't have to write that one down. This is the one that I want you to write down, okay? Deductive reasoning is something that you all do all the time. You all gather facts in your head and you come to a conclusion. In high school, most of you all gather false facts because somebody said something about somebody and you come to a conclusion that wasn't even true.
Gossip.
Gossip, yes. Gossip is deductive reasoning usually. But the difference is with deductive is that it's logically reasoning, okay? So basically they're going to give us a problem and we're going to have to figure out if that is true or not based upon deductive reasoning. Now, the biggest thing here is counterexample. A counterexample is an example showing something as false. Okay? So here's an example. All people with brown hair have brown eyes. Is that true?
No.
Why?
Because it's not.
But why?
Because I got brown hair and I got.
Exactly. You are a counterexample to my statement. Okay? If I said all people with red hair have a dog.
I don't have a dog.
Exactly. You are a counterexample to my statement.
I have a dog.
Okay, so a counterexample is a example showing that something is false. Now, if something is true, you don't need to give any examples. But if something is false, you have to give an example showing that it's false. And we're going to do that with math. So the directions say, is the statement true or false? If it's true, you write true and you stop there. If it's false, give a counterexample. All right, so here's the first one. It says for all real numbers A and B, A times B is equal to B plus A. Do you think that that's true or false?
False.
I think it's false too. But here's what you do. Let's say you're looking at it and you're like, I have no idea if that's true or false. Pick some numbers and plug them in, okay? So let's say, I don't know, I want A to be 4 and B to be 5. So I'm going to say, okay, 4 times 5 is equal to, and we said B is 5, 5 plus 4. You can pick any numbers. Do not pick 0 or 1 though, because those give false positives, and we don't want a false positive, okay? All right, so what is 4 times 5? 20. And what's 5 plus 4? So we know that this is false because that's not true, and this right here is my counterexample. You only have to give a counterexample if it's false. If it's true, write true, done. I'll look at another one. It says for all real numbers A, B, and C, A plus B in parentheses plus C is equal to B plus A plus C in parentheses. What do y'all think?
True.
It's true because why? What property did we just learn this is?
Associated.
This is the associative property. So I just write true and I'm done. Now, let's say you're out there and you're like, how the heck does she know that's true? You can always make up an example and figure that out. So let's say, I'm just going to pick somebody. Luke's over there and he's like, well, how the heck does she know that's true? Pick some numbers. So like I would do like 2, 3, 4, and then B is 3, A is 2, C is 4. And I'm going to see if this works out. Okay? So 2 plus 3 is 5, and 5 plus 4 is 9, right? Over here it says I do parentheses first, so 2 plus 4 is 6, and 6 plus 3 is 9. So it is right, it is true.
You don't even need to work out all of that. All you have to say is it's addition.
Well, you could say that it's associative from addition. Yeah, you're right. All right, this one. For all real numbers, A and B, A minus B is equal to B minus A. It is false. And if you're not sure, pick 2 numbers. So how about I pick 5 and 2? And then I'll make this one 5 and, well, here I am writing it down, 2 and 5. 2 and 5. So what is 5 minus 2?
3.
What is 2 minus 5?
-3.
Negative 3. Are those equal?
No.
No, so that's how I know that this is false. This is my counterexample showing that it's false. Because if it's false, you do have to give a counterexample. Okay, is everybody all right on those? All right, so we're done. We got about 5 minutes. You can get started on this. You can go to the bathroom. I'm trying to think who else asked me something. Finish that other homework. Yeah.